YA. I can speculate based upon previous students.
I would have thought it was A because that was the starting point.
But what's happening at the very start of the problem?
Changing direction.
Wait, sorry?
Change the position.
It's after he lets it go.
That's the key right there. It's after he's let go. At time A, the ball's out of the hand. People who want to put A at the beginning, put A at 0 is they're picturing the ball here. And not after it's not touching the hand anymore. I didn't understand, I think it was Erica, you were talking?
I was just saying to change the position, because it's leaving his hand. I get it. I was just.
So why would it be B? Because that's the B to it?
Yes. That's the point when it turns around.
Okay.
And one of the other things is that you can't go from positive to negative without going through 0. You have to, unless there's a rip in the space-time continuum, which is out of scope for the course, and hopefully reality. So when is the velocity positive? I assume that was your answer right there.
Either one.
That's being gestured from the back. Thank you for picking that finger. So whenever it's going up, which is, well, basically, it's already going up at the beginning of the problem, and we already have B over here. And then when it falls. And again, it's not touching the ground, so we don't have to worry about it stopping at the end. So it's 0 here, positive, positive, negative, negative, negative. Or over here, positive, 0.
So that's including A, but not including B.
Correct. Because as we come back from commercial, the ball is already in the air, moving upwards. And now acceleration. Who's feeling confident?
Yeah, A and B,
What's that A and B?
positive,
Why?
because it's going up.
Ooh, that tells you velocity.
Oh, okay.
Velocity cares about the direction you're going in.
Well, because both of them, because, I guess, because if they're going in the same direction, it would be positive. I don't know.
Right. Remember, velocity and acceleration, if it's speeding up, velocity and acceleration are the same sign. So is it, once it's left the hand, is it speeding up as it goes up?
Yeah.
It would be speeding up as it's going down, wouldn't it? 'Cause it's
I would assume so.
both.
But if you throw something in the air, it gets faster after it's left your hand?
No, if you, depending on how you throw it.
No. I'd like to see you throw something that after it's left your hand, it starts going faster up. And then the government will probably want to talk to you about your amazing abilities, and we'll never hear from her again. All right, so once it leaves your hand, it's slowing down. Because what is the force acting on it once it's left your hand?
Gravity.
Gravity, weight.
Thank you. Yes, which way is weight acting on it?
Down.
Yeah, down.
So could you put acceleration as positive, like at point A?
No. Because in order for acceleration to be positive, the total force has to be upward. What's the total force acting on the ball once it's left the hand?
Down,
Yeah.
because it's after it has left the hand.
I am making the assumption that Jedi powers are not existing in this.
Thank you for telling us, cause.
Yeah, no Jedi powers. This is one of the reasons why I had the problem start after it leaves the hand before it touches the ground, because I didn't want to mess with other forces at that moment. So there is a once it leaves the hand, the only force acting on it is the force due to gravity. That causes it to slow down as it goes up and then speed up as it goes down. And at point B, what is the acceleration? That would be a really cool effect if acceleration were 0 at the peak. That means you would throw an object into the air, it'd get to the top, and then the velocity would not change because acceleration is 0 and it would just hover.
It's getting faster.
What'd you say, Lane?
It's getting faster.
At the peak?
Okay, so when it starts going down, it's going downward faster.
Okay, it is getting faster as it goes down, it slows down as it goes up, and then at point B,
It would be negative.
it still would be negative, because the total force is still downwards. This is the point when I'm going from a positive to a negative value here. It's negative the entire time.
Is that the whole time because of the force acted on it?
Yes.
Okay.
Ultimately, yes.
Okay.
From a numeric point of view, and I did examples purposefully with this sort of thing in mind, if I go 5, 0, -5, so it's going in the positive direction if this is velocity. Going in the positive direction, then it's going to 0, and then it's going in the negative direction. My velocity is changing, -5,
Oh, that's what
-5, or over the whole time, -10.
I didn't catch that the last time you did that.
So it is negative the entire time. Primarily, the easiest way in this particular case is to think about the force on it once it's left the hand is just the force of gravity. You can go through F-town, do the force diagram. All right. Are there questions before I talk about the different formats? Like,
We have a chance to practice this again before we have it on like a test.
all right, so if you want to practice this again, there's Master Set 2, as well as, at this point, I've posted a video with the solutions of all Master Set, so you got that to practice on. Old tests, there's going to be some problems similar to this on a lot of the old tests. Well, actually similar to the problem we do next. Some of the early tests, I do this problem for some of the early tests, and then I got to the point where I thought, this is too simple for my students. And so, we're about to do a test level problem, but yeah, there are old tests. If there's an old test where the solution is not given to it and you need the solution, just ask. For 151, I've got a whole lot of select solutions, and that's because I had a particular student who said, hey, could you write out the solutions for these problems? And he handed me a list of problems he wanted solutions for. Sure. So I did all the solutions for him. Did it by hand, took a picture, posted it. All right, so let's talk about the different formats. If you look at the older tests, and I think all the tests that are posted, I basically, the way I have you expressing the answer is I'm asking you to use this notation with the brackets and parentheses and just the plain old letters. And that really was an issue for a number of students. I also didn't present it this way. I presented it as in, where is x greater than 0, where is it equal to 0, where is it less than 0, and then you would just write out here, AD, and then not applicable, and so on. And at some point, I kind of clued in. I thought, well, I'm asking students to do it this way, but this is what we did in class. And then one of the issues with this, I like the fact that it's nice and compact. This will look a whole lot like some of the older tests. I think all the tests I posted, I think I changed it after a different class. At some point, I haven't posted every single test I've ever written. But some students kept leaving stuff blank. For instance, if they duplicated. If somebody had written that, well, C is now in 2 locations. They have C being positive and 0 at the exact same time. And it won't do that. We'll make an argument for quantum physics doing it there, maybe, but still. So I thought, Well, we could do it this way, and this way students could see that, oh, I've already shaded in that column right there for position, so I'm not gonna shade anything else. But some students still like shading in boxes, and so I would see this, and then I would see something like that, indicating that the position was positive and 0 at the exact same time. And so there's this display, where you're filling in a box with an X or a 0 or a negative sign. At the end of it, if there are any boxes that are empty, you're missing something. So on the test that you will, on test 1, you will see the problem where I set it up. It'll be more complex than this, but the problem that I'm gonna set up. And then if you turn the page, there's 4 different formats. Pick one. One format, the first format I believe is this. Second format is like that. I think this is the third format, and that's the fourth format. Please don't do more than one format. But if you do more than one format, please give the same answers. I did have a student in the spring who filled out all 4 formats, and they were not all the same answers.
Just pick the one that's right.
I graded all 4 and then averaged them. That's what I ended up doing.
Okay.
Yeah, it was, yeah. So, there's also a PowerPoint where I go through an example step by step as well with an object moving horizontally, and we're about to do one with an object moving horizontally. Right. Any questions at the moment? All right, I'm gonna write up the next problem. If you need to stretch your legs, stretch your legs. Take a small little break here as I write up the problem.
Mr. So you're talking about some tests that you gotta, is that something I can see?
So what?
Some tests that you said you posted or something like that, some
Oh,
old tests?
yeah, if you go to, I think it's course docs,
Mm-hmm.
the first thing I think is full test, and you click on that, and you just look for test 1, and it should all be test 1s and then test 4, I think.
Oh, so I'm just checking them out, seeing how you formatted them or something?
Yeah, the way I formatted them, I don't know if any of the tests that I posted have the 4 formats. I'd have to look again, and Master Set 2, I have the 4 formats posted.
say moment or movement?
I suspect moment, but where are you looking?
On just all of them, I couldn't tell.
Yeah, they're moment. All right, I suggest we look at this as a group. You will have your own opportunity to do this solo, or something like this solo, but this is a test level problem. By the way, when I do my grading, I have this, similar to the way that the shaded version was, when I was shading in across, and I had all these across the top, and then I had the 12 different rows. That's basically how I do my grading, is I translate what you wrote down into something like that. All right, so, oh, yeah, to the right's positive, oh, and there's 0. Again, starting point and origin are not the same thing, as is part of the plan for this problem.
Let me see this.
All right, so, position. Where's position positive? Or let's actually start out with zeros. Where's position 0?
A.
See.
And E.
This is where 0 is.
Oh, 0. Gotcha.
So position is 0 at C and E. Yeah, E is, ooh, I didn't actually write that. Same position as at time C.
What do you have for G? Like, what is that?
Same position as time B.
Yep. Those are the ditto marks.
Okay.
Same position as at
Oh.
time A. Right, so it's 0 at C and E. All right, where, so once we've established 0, where's positive? Nathan?
To the right.
You said D? D is, but let's not forget the stuff in between. So it is not including C and E because that is a horrible marker. Ooh, yeah, nice. All right. So if you just wrote the letter D, if we think about over here, even though it's positive, and those 3, if you just wrote the letter D, you're leaving out a third of the area. That's 0 there. And where's it negative? Going with the hand gesture back there, basically everything else. So A to C, not including C, but it does include A because A is part of the problem. And then E to I, includes I, not E. Yes, Lynn.
On that chart, why'd you put
Oh,
those, your negative and positive in
and this is film for the world to see.
it?
Thank you very much. It'd probably been simpler just to switch the plus and minus signs. There you go. I believe it was spoken correctly, just not written down correctly. Thank you.
Okay.
Yeah, on the ball problem, we did that right. All right, so now displacement.
And that's based off of your starting point, which
Yes.
is A.
Start with
So that's A is your
correct.
starting point.